Okay, well, welcome everyone. Today's lecture, this lecture, is going to be fairly short. I'm just going to talk briefly about matter. So the reason I'm even talking about matter is because the study of chemistry is all about matter. That is fundamentally what chemistry is a study of. So I'm going to break it down through these small videos here, or short videos. All I want to talk about right now is just what the different states of matter are. And you're probably somewhat familiar with these already. They are, of course, solid, liquid, and gas. So matter exists in three physical states, and the differences between them, the difference between solid, liquid, and gas are really based on whether their volume and or shape are what we call are definite or indefinite. So when we say definite, we mean it's fixed. It doesn't change. And this can apply to either shape or volume. It means it doesn't change no matter what container we put it in. Or indefinite, meaning that the property we're talking about, shape or volume, is dictated by the container it's in. And I'll show you the examples and explain what we're talking about. And I'll show you at a sort of an atomic level, molecular level, why these states of matter have these properties that they do. So solid, as you're probably familiar with, has a definite shape and a definite volume. So this means that if I take a solid object and I put it in another container, it doesn't change its shape and it doesn't change its volume. So an example is this lovely cat figurine here. So if I were to put this cat figurine in another container, it wouldn't change its shape. It would still look like a cat. And whatever volume it is, say, 300 milliliters, it would still be 300 milliliters when you put it in another container. Liquid has an indefinite shape but a definite volume. So 30 milliliters of water is still 30 milliliters of water no matter what container I put it in. It doesn't expand to become 100 milliliters of water, but the shape is fluid. This is what we're used to thinking of when we think of liquids. The shape is fluid, so it takes the shape of whatever container it's in. And the gas has an indefinite shape, meaning its shape is dictated only by the container it's in. It doesn't have a fixed, constant shape, but also its volume is. So this is different. Gases, when you if I have 30 milliliters of gas, say in one container, and then I put it into a container that's evacuated, it's a vacuum, it has nothing in it, that's 100 milliliters, that 30 milliliters of gas will expand to fill the 100 milliliters. Now, of course, it's going to be more spread out, but its volume is just whatever room you give it. So it expands to take up whatever space it's given. So a gas would be like this little container of chlorine gas here. So the reason we see these properties develop is if we have a solid, the molecules are very, very, very close together. It's important to understand, and this may seem counterintuitive at first, that the molecules are going to be, they're still moving. They still have some motion. So even in a solid object, like that beautiful cat figurine I showed you, the molecules are still vibrating in a very small way. So they're vibrating in place. But what's happening here is the molecules, and we're going to talk about why much later in the quarter. We have a lot to get to before we can get there. But the molecules are all stuck together. They can't break away from one another. So it's like being jammed and stuck and totally, unable to move. So these particles so if there's a part of the solid that juts out, that's not going to change, right? They can't move away from each other. A liquid, on the other hand, I totally spelled that wrong. Liquid, on the other hand, the particles are close together, but this is more like being in a very big crowd, but you can still move around. They're still bumping into each other. They're still in contact, which I haven't really shown very well. But they're still bumping into each other, like if you're trying to move through a really heavy crowd and you can't avoid slamming into people. But they can still move past one another. So this is why if you had a jut sticking out, the particles would flow past one another and move and take up whatever volume or take up whatever shape that the container allows. Gases, on the other hand, are particles that are basically not in contact with each other except for when they collide and bounce off of one another. So gases, the particles are just completely spread apart, which is why they can take up any volume that you give them, because they're just going to bounce freely through the container, taking up all the space. So, if you imagine on a continuum, solid over here at the low energy, right? Because it takes, you have to put in energy in the form of heat to make solid and melt to a liquid and then boil to a gas. And gas over here at the high energy, take a moment and think about, where should I put liquid on this continuum? Should liquid be smack in the middle here? Or should it be closer to a gas? Or should it be closer to a solid? So think about that for a moment. The answer is that, and you can always, of course, pause the video and think about this before I spoil the answer, but the answer is that a liquid really belongs, so if solid is here, solid is here, and the gas is here, a liquid's about here. A liquid is a lot closer. It takes a lot more energy to boil a liquid into a gas than it does to melt a solid into a liquid. And that's really all I have to say about solids, liquids, and gases for now. We'll come back to this in a lot more detail later, but that's really it for the moment.